So fatigue and recovery. So there's three different types of fatigue. You've got local, so it's like localized muscles like your biceps, triceps, or hamstrings. So you'll feel like this kind of burning sensation. General, so if you've been maybe doing football, you're maybe feeling like you'd just be getting the general like fatigue just all over. And then you got chronic where it's like everywhere over the time. So it's sort of like if you've been to the gym and worked at every muscle component, when you walk you'll just feel achy like all over your body. So what determines fatigue is like really the intensity you work at, the duration you work at, the type of sport you are doing, the fuel what's used. So if you're working for short, like carbohydrates, the individual's fitness levels. So obviously, if you're fitter, the less likely you're going to get so much fatigue. Then if you're really unfit, you're going to get fatigue a lot quicker. And what type of systems have been used. So firstly, during maximal intensity and very short duration, so the type of this is what's going to like determine really your fatigue and your recovery. So in this example, like something like javelin, what's really short, you're using the ATP system. This is very short duration, so it's like something like 3 seconds max. And you're using the fuel for carbohydrates, which means you're working anaerobically. So by working anaerobically, you're going to have a very high O2 deficit because you're never going to really, or never ever going to reach steady state. The neuromuscular recruitment you're going to use is fast glycolytic because it's fast, powerful movements. So you need as much power as possible. And you'll never really feel fatigue after this. Maybe if you're doing it for long periods of time. So doing like, let's say javelin, you're doing like 20 javelins back to back. You're going to maybe feel a bit fatigued, but then the duration intensity would have changed as well. So it wouldn't be this example. Let's go back one. So the next one is moderate intensity and moderate duration, so like a 400-meter sprint. It's you're working like at a short duration, so it's only a couple of minutes. At very high intensity, you're using the carbohydrates still, and maybe you go into the ATP and PC system, which you'll be totally depleted. So this means you to help them with this, you take PC supplements, and this is oh god. So the PC supplement is done so before an event. This can be taken to increase the size of our PC stores. This allows us to work for longer rather than it being depleted so quickly. But it can also replenish the PC system much quicker, so it allows muscle contraction after it's been used. Also, other things, lactic acid system. So this can be helped by soda loading. So soda loading is like an attempt to neutralise the lactic acid that accumulates in the blood. This is done by like taking. So the theory says that by taking bicarbonate appears naturally in the blood and acts like a buffering system. So this has an important role. So this is an important role. So buffering lactic acid. So loading the system by ingesting large amounts of baking soda, which is sodium bicarbonate, in advance of an event should help increase the amount of bicarbonate in the blood, making the blood much more alkaline, and therefore this increases anaerobic endurance because by limiting lactic acid build-up, which is like hydrogen ions, which accumulate both. And this is believed to inhibit muscle contraction and metabolic processes. This allows the result of fatigue and the inability to continue working at the same intensity. Also, for this, you need a high fitness level. you're using fast glycolytic muscle fibres, and it can sort of be continuous. For submaximal intensity and hydration, you use the ATP PC system, and you might go into the lactic acid system. You're using both carbohydrates and fats. You're working at a high intensity. You need high fitness levels, and you can do continuous exercise. Also, during this, glycogen depletion happens in stores. So as you can see on the first graph on the top left is how so in light exercise, you don't really use much glycogen. It stays pretty much the same. Moderate exercise, it goes right down, or it goes right down to the bottom, but in a shorter period of time. And in heavy exercise, so high intensity, you're using it really quick. So the longer the exercise, the more glycogen which is used up. So in a 100-meter sprint, which is around about 9 to 20%, approximately 5% of glycogen would be used up. So the glycogen is, the glucose is stored in the muscle and liver, but the liver stores it as glycogen, so it will convert into glycogen to be saved, and then it will be converted back into glucose to be used up. The muscles store it as glucose. So when you exercise, your muscle glucose will be used up first, and then if you need more, it will go into its liver. And lactate can also turn into glucose. Also, the one at the bottom is stores of glycogen again. So day one, you have very high levels of glycogen stores, but then you go down, and then after exercise and training, your glycogen stores go lower. So obviously you've used some glycogen, but then it gets replenished by day two. But as you can see, not as much as you started off with, and the same pattern happens that you use a lot more up at the end of the session, but then it replenishes a bit more, but never replenishes its full amount. So to change this, or the rest in between high levels of exercise will allow the glycogen stores to reboot. So basically, the longer break you have between exercise, maybe you have a couple of days off, will allow your glycogen levels to be replenished. So ways to reduce this is by doing glycogen loading. This improves endurance exercise in events lasting more than 90 minutes. And muscle glycogen availability is maintained at a high intensity and intermittent events, according to Balsam et al. So the best way to do it normally, if you're doing long distance over 90 minutes, is you normally deplete your glycogen stores maybe a week before, and then a couple of days you just take in large amounts of glycogen, which will be stored already for your event. So in intermittent activities, for example, netball, you wouldn't reach steady state because all the time different systems are used, different intensities, different durations. So, for example, the AT system would be used maybe when someone's sprinting to receive the ball. The lactic acid system may be used if you'd continue trying to defend the ball, where you might not be such sharp movements. And the aerobic system, you could say maybe running back to your position, because the netball court is quite short, that you probably won't be using the aerobic system very much. So fatigue would happen maybe a bit during aerobic or lactic acid, but you wouldn't really receive much fatigue in netball because it's quick, but then it's followed by quite a long breaks. So recovery. So strategies to aid recovery is by taking a high carbohydrate diet. and maybe massage after cryotherapy, or you can have mental recovery by doing visualization, meditation, or controlling your breathing. So this graph on the side is showing you, so at the start, like here, this is showing, so you see this white area is showing the oxygen consumption during your activity. So here they're taking that much oxygen, and then when they get to the top, they're literally just reaching steady state. The E in purple is showing your oxygen deficit. So this is all the oxygen they should be taking in, but they haven't. And then this is the bit we're mainly looking at, is the recovery part. So A is your fast component recovery, where you're doing alactic recovery, and this is between 2 to 3 minutes after an event, so it happened very quickly. But then you have D, and this is your slow component, and this is lactic acid recovery really, and it takes up to 2 hours. So this is just breaking down all the lactic acid and turning it back into glucose or something, and it takes a lot longer. So firstly, recovery for max intensity and short duration. So the recovery is generally under 10 seconds, but also depends on what fuel you've actually used and maybe the intensity you've used at. But thinking with javelin, it would probably not even be 10 seconds. Because you never reach steady state. And also low epoch, and this is the epoch, so this is being what's got the fast and slow component recovery, and this is where it replenishes my myoglobin and hyoglobin. So recovery is pretty simple for that one. For moderate intensity and moderate duration, you have a larger O2 deficit because you never actually reach steady state. Your anaerobic rep, you don't use anaerobic system, and you use more lactic acid. So this leaves you with like a larger epoch, which means you have much slower recovery because the more lactic acid you build up, the slower it will be. And when I've got a circle here is your metabolic demand, so this is recovering all of that. And sometimes the muscle PC levels can be almost totally gone from this type of intensity and duration. During submaximal intensity and high duration, you have a smaller O2 deficit because you have more time to reach steady state because you're not working at such a high intensity, and you do reach steady state quicker. It's mostly aerobic respiration, so you're taking in a lot more oxygen, what's leaving you with a smaller oxygen deficit, what's going to help with your recovery. So less lactic acid will be built up because the oxygen is continually breaking it down into like CO2 and stuff. So it means quick recovery and less VO2 is consumed. During intermittent activities, it really depends what type of activity you're doing. So the interval training influences the depletion. And this type of training can increase ATP and PC stores. So as you can see here, when you have a high PC ATP system, it gets depleted, but then during recovery, it goes a lot, then gets replenished. But at each time, the replenishment during that activity gets a bit smaller. So that's when you need like maybe longer recovery time. But it also really just depends on if you've been doing more in the aerobic system. You can obviously need a lot more, you won't need as much recovery because you'll have less epoch. But then if you've been doing a lot of anaerobic, it means that you can have more lactic acid buildup, so you will have a large epoch. So it really depends on what type of intensity you're playing at, which means what type of recovery you have.